Today we're going to do chapter 6. These are the answers for today's questions. Questions 1. An inductor with an inductance of 90 millihenry is connected to a 12-volt AC supply with a frequency of 50 Hz. Calculate A. The reactance of the inductor. B. The RMS current of the circuit. C. The maximum instantaneous power. Questions A. Determine the reactance of the inductor. Now, since you are given the frequency and the inductance of the inductor, therefore you can solve it by apply the equation for inductive reactance. So XL equals to 2 pi FL. Substitute the values into the equations and you will obtain XL equals to 28.27 ohm. Questions B. Determine the RMS current of the circuit. Now, since this is a pure L circuit, so you can solve it by applying equations VRMS L equals to IRMS XL. Now, if you're going to calculate IRMS, then you have to make sure the V is the RMS value as well. But if you look at the question didn't mention anything about the V. It didn't tell you whether it is VRMS, V instantaneous, or V peak. Therefore, in our syllabus, we are just going to assume that is the RMS value. And again, since you are going to calculate, you are going to use the V across L. Therefore, you have to use XL in the calculations. So you have to make sure they are coming from the same family before you solve that. RMS and RMS, L and L. So next, just substitute the values into the equations and you will get IRMS equals to 0.424 ampere. Question C. Calculate the maximum instantaneous power. Now, one thing that you have to remember, maximum power, it doesn't represent peak power. Peak power is the power calculated by using peak voltage and peak current. Then how about maximum power then? Let's look at the graph for inductor. Now, this is a graph for inductor. If you look at the graph, the maximum point of the graph, the maximum value of the graph is P peak divided by 2. It is just half of the peak power. That's what I told you just now. Maximum power is not equal to the peak power. So now let us see how are we going to solve it. So according to the graph, P maximum is P peak over 2. Substitute I peak and V peak into the equations. And now we're going to simplify it furthermore because we don't have the peak value. So I peak is equal to square root IRMS. V peak is equal to square root VRMS. Now that you have this equation, simplify it and you will get P maximum is equal to IRMS VRMS for inductor. And next, just substitute the values into the equations and you will get P maximum equals to 5.09 watt. Questions 2. A capacitor with a capacitance of 46 microfarad is connected to a 6-volt AC supply. If the frequency in the AC is 100 Hz, calculate A. the reactance, B. the RMS current of the circuit, C. the average power. Questions A. Calculate the reactance. Now, since this is a pure C circuit, so obviously it's looking for capacitive reactance. So apply the equation for capacitive reactance. Xc equals to 1 over 2 pi Fc. Substitute the values into the equations and you will obtain Xc equals to 34.6 ohm. Questions B. Calculate the RMS current of the circuit. So this is a pure C circuit, therefore apply VRMS C equals to IRMS XC. So once again, as you can see here, since I want to calculate IRMS, I use VRMS. And since this is a pure C circuit, so if V is a cross capacitor, then in your equation, you should substitute here as XC. Next, just substitute the values into the equations and you will get IRMS equals to 0.173 ampere. Question C. Calculate the average power. Now, capacitor and inductor, they have the same type of the graph and their graph is different than the resistor. And the ways to calculate power is also slightly different. That is because for capacitor and inductor, both of them, they just store the power and then give it back to the circuit, return to the circuit. But for resistor, it's going to consume. Therefore, now when it comes to the graph, this is the graph for L and C. For R, the graph would be located above the X component because it just absorbs the power without being returned to the power supply. If you look at the graph for C and L, the maximum power is peak over 2, peak power divided by 2. So in this case, the average power will be the midpoint. So where is the midpoint? If you look at the graph, the midpoint of P peak divided by 2 and negative P peak divided by 2 is 0. Therefore, the average power for capacitor and for inductor, both of them, they are equal to 0. Question 3. A capacitor of 1500 microfarad is connected to 2.5 volt 0.45 ampere lamp and a 60 Hz power supply in series. Calculate A. The voltage across the capacitor, B. The voltage across the lamp, C. The source voltage, D. The impedance of the circuit. To calculate the voltage across the capacitor, let's apply the equations for voltage across the capacitor. So VC equals to IXC. As you can see, both of them, they are coming from the same family, which is a capacitor family. Now we're going to calculate the capacitive reactance because we still don't have the value. What we have is just a capacitance. So don't get confused between capacitive reactance and capacitance. So Xc is equal to 1 over 2 pi Fc. Substitute the values into the equations and you will get Xc equals to 1.768 ohm. Now that we have capacitive reactance, let us calculate the voltage across the capacitor. Given Vc equals to Ixc, we have Xc, but how about I? According to the questions, now you have 0.45 ampere flowing through the lamp. So when it comes to an electrical circuit, lamp is actually a form of resistor. So this is a circuit that we have right now. And if you look at the diagram, they are all being connected in series. So if the current flowing through the lamp is 0.45 ampere, it means the current for capacitor is also 0.45 ampere. So let's substitute the values into the equations and you will get Vc equals to 0.8 volt. Question B determines the voltage across the lamp. Now, if you understand the questions, the voltage given in the questions it actually belongs to the lamp. Therefore, in this case, the voltage across the lamp is the VR and it is equals to 2.5 volt. Question C, the source voltage. So how to calculate the source voltage? Now, you cannot just simply add up VR and VC. Why? Because they are not in phase. So since this is an RC circuit, how are we going to calculate that? I would suggest you to sketch the phasor diagram first so that you can see what is the relationship between V source, VR, and VC. So this is a diagram. VR is lying on the X component and VC lags behind VR. So they are not in phase. That is the main reasons why I told you you cannot just simply add them up. So to calculate V source, which is here the resultant V, so you have to apply equation V equals to square root VR squared plus VC squared. Substitute the values into the equation. V source is equals to 2.62 volt. Question D. Calculate the impedance of the circuit. So apply the equations for impedance. You have Vs equals to Iz. Vs is a resultant voltage and Z Well, you can say it is a resultant for resistance and reactance. So which means Vs and Z, they are coming from the same family. Just like the equations Vc equals to Ixc, Vc and Xc are coming from the same family. Vl equals to Ixl, while Vl and Xl, they are coming from the same family. So next, just plug in the value and you will get Z equals to 5.82 ohm. So that's all for today. I will see you again tomorrow.